Hi all, welcome to another code snippet discussion. So right now you're viewing the code snippet which I've shared on my Telegram channel today. So this code snippet is going to mainly focus on the constructors and the invocation of the constructors, the inheritance, and what happens post inheriting a class and how the base class constructors are getting invoked. So a lot of concepts are involved in this, and let's go ahead and understand them line by line more in detail, so that we will come to a conclusion how this code snippet can be understood before we derive with an output of this code snippet. So the first thing is let's get into the IDE and create a class called rainforest. So right now we have a class here called rainforest, and we also need to create a class called forest, and the rainforest is going to extend the forest class. So this is the main theme behind this code snippet. So let's straight away get into our IDE and start creating the class called rainforest. So the first class that I'm going to create here is rainforest and rainforest, and let's carry the main method and zoom in. So here we have the base template, and from here let's go ahead and create another class that is essentially required here called forest. So we have a class called forest, and this forest is going to carry a variable called tree count. So this is of type long. Okay, it's a long type, and it is coming from the integer family, and this is an instance variable. Okay, so this is an instance variable, and it has a default value initialized to this variable called 0. Okay, so let's understand that part pretty clear, and now let's go for creating a constructor for this class called forest, and that too it's going to be a argumented constructor. So long tree count, right? So now if you focus here, the one thing that we have to understand in this constructor is it's an explicit constructor. We have written an explicit constructor, and the default constructor is overridden to explicit constructor. Default constructor is overridden with explicit constructor, and that too it is an explicit argumented constructor. We carry a single argument here, right? So it's an argumented constructor. Okay, so why I'm stressing out here is because this is the key part here in this particular code snippet. So let's go ahead into the constructor of forest and use this keyword to invoke the tree count. So why we use this keyword is because we need to invoke the instance variable. Probably in my earlier code snippet discussions, I would have preferred of not using this keyword. It's because there might not be much of a conflict. So by default, that implicitly that this will be applied. But that's not the case here. We need to explicitly use the this keyword in order to differentiate the parameter variable. The parameter variable name and the instance variable names are same. So in order to differentiate them, okay, you need to use this keyword. So whenever we use this keyword, it's going to point to this instance variable, and we are going to assign the local variable value to this instance variable. So that's how it's been framed out. So let's go ahead and use tree count. Okay, so now the local variable, actually we tend to call it as local variable, but it is a parameter variable. Parameter variable is none other than a local variable. Okay, so this local variable is going to be assigned to this instance variable. That's how this constructor have been designed. Okay, so next thing is coming into the rainforest class. Okay, the rainforest class, we are going to carry one constructor, and that too it is again an explicit constructor, and the understanding is the default constructor of the rainforest is going to be overwritten to explicit constructor rainforest. So the constructor name should be the same name as the class name, and this is also going to carry an argument called tree count. Okay, tree count, and inside this again we are going to use this dot tree count equals tree count, but there will be a compilation error that might occur. Okay, that's because we don't have the tree count variable here in the rainforest. If you see, the forest class is having a tree count variable, but there is no instance variable called tree count declared in this rainforest. So we are not going to do that because we are going to extend. So I'm going to use extends forest. So forest is a base class, and I'm going to extend the forest class into the rainforest. So rainforest becomes the child and forest becomes the parent. And again, to recall, forest is extending the base topmost class called object. I am trying to recall this again and again so that it gets registered in our mind thoroughly. Okay, so anytime when you go and look forward for a code snippet, you should calculate with all these implicit implementations as well. You should not forget that. Okay, so rainforest, which is extending a forest class, is ending up with an error. It makes the compiler to throw an error stating the line number 13 is a compilation error problem. So why there is a compilation problem? Let's explore that. So if you notice here, what's actually happening is when I hover the cursor, it states there is an implicit superconstructor forest is undefined, must explicitly invoke another constructor. So this is the problem here. Okay, so in this case we have an issue saying the implicit superconstructor forest is undefined. So meaning is we don't have the default constructor of the forest or the no argumented constructor. So that's the problem here. Please make a note of it. This particular rainforest is actually applying a keyword called super of. This is by default there. So super keyword is used to call superclass constructor. Super keyword is used to call superclass constructor, right? So now when I'm using that super of, means the superclass, we don't have any default constructor nor the no argumented constructor. We have only argumented constructor, right? We have only the argumented constructor, and that's the reason that this is ending up with an error. So whether you apply it explicitly with the super of or you don't use this line at all, it is going to be the same. So if it is going to be the same, means implicitly there is a super of call happens every time when a class extends another class. In the child class constructor, there will be an implicit super of call will happen. Super keyword is used to refer the super class from the child class. So super of is there. Whether you explicitly write it or you don't write them out there, it will carry a super of. Now what they are saying is when you have super of, it is looking out for a default constructor of the forest or the no argumented constructor. So let's try to resolve this error shortly by using let's say forest of, and this is going to be called as the no argumented constructor. So no argumented constructor is getting invoked. That's the meaning here. So when we have super of here, means it's calling this no argumented forest class constructor. So now there is no challenge. The compiler is not facing any trouble. So it says it's pretty good. So we can think of that having a no argumented constructor will help us in eliminating this issue. But in our code snippet, we don't have this either, right? So there is a chance of error still existing. So what they are saying is either you have a super of defaulted or you write a super of and you pass on the tree count, right? So by this way, we are explicitly writing a super of, means we are calling the super class argumented constructor. Explicitly, we are calling the super of argumented constructor, means the super class argumented constructor is specifically invoked. So what happened to the default super of? We are not we are not including that line, because that line is getting replaced with super of and calling the argumented constructor. By this way, again, the error will get resolved. Even this is not there in our code snippet. So that's the point here, right? If you look at here, there is no super of call explicitly called. It is only calling the implicit super of. It is only calling the constructor through the implicit super of, and we don't even have the no argumented constructor either. So obviously this will be a challenge. So if I remove the super of, then it will end up with an error. So now as per this code snippet, at last we have a sysout which is creating a rainforest instance and calling the tree count. Will not make any sense, because we already end up with an compilation error. So we have to find out a way to resolve the compilation error. So let's keep intact with the code snippet that we have seen on the image. So new rainforest of the value is 5 dot tree count. Okay, so what is the outcome of this code snippet? The outcome of this code snippet is nothing but your compilation error. So this code snippet ends up with a compilation error. So how do we go ahead and resolve this error? The one way is you either create a no argumented constructor here on the forest class, or you better invoke the base class argumented constructor using the super of. So that's the good habit. After this super of, you can have as many number of lines you can write it inside the constructor. But the super of keyword have to be called on the very first line. That's another important point. The catch here is the super of call should be placed on the very first line of the constructor. It cannot be placed on the 6th line or 5th line. Super of should be the very first call that need to be made from the very first line of a constructor. Okay, so now we have kept that intact. So now what happens is compilation problem is resolved. Now this 5 will be passed on to the rainforest argumented constructor, and that 5 is again forwarded to the forest class tree count, and that's been set to the tree count variable, okay, the instance variable. And technically here we are also assigning this tree count variable value to this dot tree count. So let's go ahead and execute this and see what's the outcome of this program. So this is not the actual outcome of the code snippet. So right now it says 5. That's good, because we have passed on 5 and the 5 is set to the tree count. This dot tree count equals tree count. So the rainforest tree count variable is going to carry the 5. So from where this tree count comes from? The tree count is coming from the forest. We don't have a tree count in rainforest, but it's inherited from forest. So rainforest is carrying a tree count which is inherited from the forest. So what if in case we don't write this line number 16, and we just halt with the super of and forward the tree count there? So if I go ahead and run this, so still you get the output of 5. There's no much of a difference, because you are setting the value of the tree count through the forest class constructor. Okay, so that's what is happening here. So the 5 which is forwarded to the rainforest is in turn forwarded to the forest and set to the tree count. Okay, so the new rainforest of 5 dot tree count will carry the value of 5. So now the understanding is the super call. Okay, the super call is the culprit here. The default super call is not allowing the snippet to compile, because we don't have a default constructor, neither default constructor nor the explicit no argumented constructor. So in order to resolve that problem, we have explicitly written a super of in order to call the exclusive nor argumented constructor. Exclusively we are calling the argumented constructor in order to resolve the issue, and we go ahead and create an instance for rainforest and invoke the tree count. And since it's inheritable, you're passing the value to the base class and set the value and get the value. So that's what this code snippet is all about. If in case you have any queries, please share your queries on the comments, and then I'll try to respond it at my best. So we'll catch up on another interesting code snippet. Until then, have a great day. Thanks.